In this video, we're going to talk about doing algebra with graphs of functions. You've probably done algebra where you have to add, subtract, divide, even do a composition of two equations. But in this video, we're going to talk about doing a few of those things just given the graph. And we'll see what that looks like, and hopefully we'll see it's not too complicated. So in this problem, we have the sketch of two piecewise linear functions. And I picked piecewise linear functions to do here just because it's kind of a nice little introduction. It's nothing special though. Doesn't really mean it. So for this problem, it says, given the graphs of f of x and g of x, sketch the graphs of h of x, which equals f of x plus g of x, j of x, which equals f of x divided by g of x, and k of x, which is the composition of g of x, which is g of f of x. It's the composition of g and f. So let's look at this first one, h of x, which is f of x plus g of x. Now, again, if you had equations, you would first add the equations together, simplify, then regraph. But here, since I already have the graphs and I don't have equations, I just add the function values, because that's what it says to do. The function values for h of x will equal the function values for f of x plus the function values for g of x. So just add the corresponding points. When x is negative 4, f is negative 1, and g is positive 1, negative 1 plus positive 1 is 0. So h of negative 4 is 0. Let's look at h of negative 3. At negative 3, f is negative 2, g is 3, 3 plus negative 2 is positive 1, so h of negative 3 is 1. And there's the first little part of my graph here. And we just keep going here. Add the corresponding points. 2 plus 4 is 6. So here we go, way up here at 6. There we are. Now when x is negative 1, 1 plus 3 is 4. Connect. Excellent. At 0, we have 3 plus negative 2, which is 1. So here we go. At 1, we have 2 plus negative 3, so now we're down to negative 1. Then here, at positive 2, there's not actually a point, there's not a dot on the f of x here. Oh my goodness, what will we do? Well, we can look at this, and because it's piecewise linear, we can see that that actually is definitely 1.5. If it wasn't linear, you can still just kind of approximate from what the graph is and get a rough estimate of where the point should be. So I can see that this is 1.5 for the f, plus negative 1, 1.5 plus negative 1 is positive 1/2. Put a dot there, connect. Next, 1 plus 3, we've got dots for both, so that's nice. So we put a point at the sum, and then 4 plus 0 is 4. Connect. And there's my graph. My graph isn't that perfect because drawing with this thing is not that great. But you just add the graphs. You're physically doing what they tell you to do. They tell you to create h of x, take f of x, which is the output, the point that I see graphed, the y value of f, plus the output, the y value of g, for the same x. And so you just add the corresponding y values and then plot those points and connect. Same thing will happen with division, but let's look at it anyway. So here we have j of x is equal to f of x divided by g of x. Now, for the first one, which was addition, it didn't matter which one, addition order does not matter. But for division, we do have to be careful that we actually take f of x divided by g of x instead of g of x divided by f of x, because that would be different. But as long as we're careful here, f is negative 1. When x is negative 4, f is negative 1 divided by g is positive 1, so negative 1 divided by positive 1 is negative 1. So there we go. Then negative 2 divided by positive 3 is negative 2/3. And again, we just kind of approximate and put this here. It doesn't have to be, we just do our best, that's all. Then 2 divided by 4, positive 1/2. Put a dot there, positive 1/2. So again, just going along and doing the operation that they asked me to do, which in this case is division, for the corresponding, for the y values as long as it's at the same x value. 3 divided by 1 is 3. Make a dot and connect. 3 divided by negative 2 is negative 1.5. So here we go. Connect. 2 divided by negative 3 is negative 2/3. Here we go. Connect. F, again, now we're at positive 2, and that f, we have to sort of approximate that that's going to be positive 1/2 divided by negative 1, so that's a negative 1.5. Positive 1.5 divided by negative 1 is a negative 1.5. Then 1 divided by 3 is positive 1/3. And then 0 divided by 4 is 0. And connect. All right. So, of course, we could do this something similar with both multiplication and subtraction. With multiplication, just like addition, the order that you look at the two y values doesn't matter, but with subtraction, like division, it will matter, so just be careful of that. But to add or subtract or multiply or divide with the graph of a function, you're just looking at the corresponding y values. So what I mean when I say corresponding is the y value of the first function at negative 4 and the y value of the second function at that same input, negative 4, or so on. Then this last one is a little bit different. It's a composition of two functions. Let's do green for this one. Okay. So k of x is equal to g of f of x. And again, order is going to matter because g of f of x is much different than f of g of x. But the same thing is going to happen. I'm looking at making a new function, k of x, out of two old functions, f of x and g of x. So I just look at the points that were plotted for f of x and g of x on the graph and then use those. So again, let's start from the left and go across to the right. So f is inside, so that comes first. So f of negative 4. f of negative 4 is negative 1. So now I'm taking g of negative 1. Well, g of negative 1 is positive 1. So that means that the point should be negative 4, comma 1. Because the original input that I had for x was negative 4. Then f of x, f of negative 4, was negative 1. So then I'm taking g of negative 1, which spit out a positive 1. Just keep doing that over and over here. Let's look when x is negative 3. When x is negative 3, f is negative 2. So now I need to look at g of negative 2. Well, g of negative 2 is 4. So I go back to where my x was. X was negative 3. F turned that into a negative 2, and then g turned negative 2 into a negative 4, or into a positive 4. So here is the first little part of my composition here. Let's keep going across. When x is negative 2, f of x is positive 2. So now I need to figure out g of positive 2. Go over to positive 2, g is negative 1. So that means my value here for k of x is negative 1. So we connect. Oops, kind of missed that one, huh? Keep going across. When x is negative 1, f, because I'm looking at f first, is positive 3. So now I need to take g of positive 3. G of 3, 1, 2, 3, is 3. So the output here is 3. My input, my original input was x equals negative 1. My output was positive 3. So I have a dot here at positive 3. Okay. Keep going. 0. When x is 0, f comes first because it's inside, so f of 0 is positive 3. So again, I look at what is g of 1, 2, 3. G of 3 is also 3. So connect. Okay. Keep going across. When x is 1, f of 1 is 2. G of 2 is negative 1. So when x is 1, k should be negative 1. Keep going here. Now when x is 2, f, we said we could tell here is 1.5. So now I need to look at where is g when x is 1.5. So if I go over to 1.5, go down to g, well, g is right at negative 2. So my original input, x was positive 2. My output in the end for k is negative 2. So make a dot and connect. Just 2 more points here. If x is positive 3, then f spits out 1. So now I need g of 1. G of 1 is negative 3. So make a dot at negative 3 and connect. Last one, when x is 4, f is 0. What's g of 0? G of 0 is negative 2. Make a dot, connect. So this last one, this composition, can be a little bit tricky because you're kind of jumping around the graph. For the first two, you were always just looking at the same x value. But what makes this last one tricky is that if we just look at that last point again real quick, just to make sure, when x, my input is 0, so I'm looking at this right here, I go and I find f. F of 0 is 0. So then, since it's g of f of x was 0, x was 0, f of 0 was 0, I'm sorry, said that wrong. X was 4, so f of 4 was 0. So now I look at g of 0, which was negative 2. So I inputted 4 for the x, and my final output after looking at f and g of f was negative 2. So I made a dot at the point 4, my original input, and negative 2, my final output. And that is how we do algebra with graphs.